Okay. So please make a proper note. We might extend our today's lecture to 3:15 or say 3:10. I will try to finish the content uh, as soon as possible, but I will like to go very slow for these topics because uh, very important topics, whatever I'm covering. Okay. Almost on all the topics which I'll be covering from today, okay, till your last lecture, almost all the topics are asked from exam. Also, maybe the previous class, okay, maybe the parity bit, maybe two-dimensional parity bit, or maybe two-dimensional parity bit, or maybe repetition code. All of this have been reflected in your previous year question papers. So please pay attention. There won't be any special classes taken for unit 4, okay, for you all to understand what is the concept. Okay, I will not waste more time. You should understand by now the severity of this subject. Okay, so today we are going to learn block codes. Okay, so block code is a type of code, okay, under which there are many different. So why it is called as a block code, we will understand. We will see why this particular codes, different types of codes are called as block codes. Okay, so block code is a broad topic. Okay, so under your block code there are different types of block code. We are going to solve one problem on block code. Okay, then there is something called as Hamming code, which is also a type of a block code. You might have learned and solved such type of problem in your data communication. Okay, might be the approach over there is little different for the problem. The approach is little different over here. Here I'm trying to teach you the way it is given in the textbook, which is given for you in the syllabus. Okay, so under block code we are going to learn Hamming code, we are going to learn linear code, we are going to learn what is cyclic code, okay, and we are going to learn what is ISBN code. Okay, what is important over here is a problem will be given to you on a particular code. Okay, for example, a linear code, a problem will be given, cyclic code, a problem will be given, Hamming code, a problem will be provided to you, block code, a problem will be provided to you. You all need to solve the problem, okay, and find out how many errors are there. Okay, where are the errors, how many errors are present when you are transmitting the data, and how to improve the errors. Okay, how to make corrections in those errors. All these things we are going to learn in this particular codes. Okay, so I am starting with the first code. If you all have any difficulty, if you all are facing any problem, any difficulty, please ping me on WhatsApp, because I am sharing the screen. I am not able to see the chat which you people are writing over here. Okay, so please, you can ping me if the screen is not visible. If you have not understood, you can please unmute your mic there only and ask me what is the difficulty. Please, but don't take these topics uh, uh, s- uh, very simple. They are not that simple. Okay, probably it will take little time for you to understand the first concept. Okay, why I am telling you all this thing? Because uh, the concept of solving the problems across your Hamming code, across your linear code, across your ISBN code, across your cyclic code, almost remains similar. Okay, the formulas always remain the similar, only there is a changes in the steps here and there. So if you understand whatever we are learning today, that is block code, it will be very easy for you all to understand the remaining topics. We can go through the remaining topics very fast. Okay, so let's start with today's topic. Okay, so we are learning block code for error correction and error detection. All in this chapter we are learning the same thing. Okay, that is error detection and error correction. So let us see what is block code for error detection and error correction. Consider that a message source can generate m equally likely message. Okay, so there is a message source, okay, from which there is a message is generated. So m is the message which is generated. Initially we represent the message by k binary digits. Okay, so this particular message is represented by k binary digits, such that 2 raised to k is equal to the whole message. So your whole message is nothing but 2 raised to k, where k is nothing but your binary digits. Okay, and these k bits are called as a information bit. Okay, then as all of you all know, whenever we are sending information across a channel, we always add redundancy to the information. Okay, to check whether the data has been sent correctly or not. We have already covered this previously. So as of now, what I'm telling over here is there is a message m. Okay, and initially we represent each message by k binary digits. Okay, such that 2 raised to k is equal to m. These k bits are nothing but information bits. Okay, now your whole message won't be only your k. Along with k, something else will also get added to it. That is nothing but a redundancy bit. Then only you will say that you are generating something which is called as code word. So as of now, we are calling this message M, okay, as 2 raised to k, and this k are nothing but information bearing bits. There is an example that is given over here. Okay, there is an example that is given over here. So this k equals 2. If your k value is equal to 2, so if you substitute it over here, what will happen? 2 raised to k. So 2 raised to 2, you will get the message 4. So there are altogether 4 messages of length 2. Okay, there are altogether 4 messages of digit length of each message will be 2 bits. Okay, altogether 4 messages, and the length of each message is 2 bits. I hope it is very much clear to you. So when the k equals 2, so I'm doing it in digital form. So how many combinations are possible? So you know your data in your computer is always represented in the form of zeros and ones. So either it can be 0, 0, it can be 0, 1, 1, 0, or 1, 1. So these are your message 1, message 2, message 3, message 4, okay, which we have generated from k equals 2. You should always, as this is very common statement, you should always know that your message should be equal to or greater than 2 raised to k. Okay, so message will be equal to or greater than 2 raised to k. In this case, 2 raised to k is 4. So message equals 4, which is correct, which we have calculated over here. Okay, is this clear to all of you? Any doubt in this? If anybody is having any doubt, please ask me. I will go very slow for this process. Okay, let us take more than 1 hour to complete it. But if you get this concept properly, you will understand the remaining 4 concepts more properly. So is it clear to all of you? Okay, so let me go to the next part. Now we cannot just send the information to the user. Along with the information, I am adding the redundant bits R. Okay, along with the information, I am adding the redundant bit R. So K is your information bit and R is your redundant bit which you are making. So I am considering my full message as K plus R. Okay, now earlier I was naming K as information bit. Okay, I was naming K as information bit. Now I have added redundant bits to this K. The moment I add my information bit with redundant bit, whatever I'm getting over here is nothing but a code word. So from your actual information, okay, from your actual message, okay, that I am going to send, okay, that is of K bits, I am adding an extra redundancy bit to make that message a code word. Please remember this. Henceforth, we are going to refer to this word code word very often. Okay, so code word is generated from your information bit plus your redundant bits which we are sending across. Okay, which we add to the message when we are sending across the message to check if the correct message has reached the receiver or not. Okay, so I hope the definition of code word is very much clear to you all. Okay, so the total number of n possible code words will be 2 raised to n. Okay, and the total number of possible messages is 2 raised to k, which we have already seen. Okay, so as of now, you don't need to worry about anything. Just remember that there is something called as k information bits. Okay, and we club this k information bit with redundant bits. Okay, and that particular bit is called as code word of length n. Okay, so the n is nothing but it is a code word of length n bits. This is more than enough for you all to remember over here. Okay. Now, how do we denote this code word? Okay, or what is this code word called, or what do you mean by block code? Okay, so codes formed by taking, okay, so codes formed by taking a block of k information bits and adding r redundant bits, okay, form a code word which I have already told you, which is called as block codes. Okay, so always whenever there is a k block of data information bits added to your R, that is nothing but redundant bit, those type of code words are called as block codes. Okay, remember, so whatever we are going to learn now, maybe Hamming code, linear code, ISBN code, cyclic code, all are block codes. Okay, whatever we are going to learn today, all are block codes. How they are designated? They are always designated as n comma k. So now the question here, as I'm saying to you, that how do we will identify which is a block code? Okay, the moment this format is given in the problem n comma k, you should identify that it is a type of a block code, and based upon whatever is given to you, for example, it might be given to you as block code, it might be given to you as linear code. Based on that, I have to follow the steps to solve the answer. Okay, to find out how many bit error is present and how to detect it and how to correct it. Moment there is n comma k. So n is what? N is nothing but, as we have already seen, it is a code word. Okay, n is nothing but, as we have seen previously, n equals k plus r. Okay, so n is your code word. Okay, and k is nothing but your actual information bits. So the moment you see any data in the form of n comma k, it is called as a block code. Okay, this particular block code is also known as systematic code. Okay, so as of now, you just remember what I have told you. What is k, what is r, what is n, what is a block code. Okay, that is more than enough for you all to learn as of now. Okay, don't take some anyway. What do you mean by a block code and how do you represent a block code? Okay, let me go further. Now in this block code we have to learn a concept called as Hamming distance. Okay, so this is altogether a different concept under your block code that we need to use. Hamming distance, you might have already learned this in data communication. So if there is a more easier method to understand what is Hamming distance in your data communication, you can follow that method. Okay, so now this is more of definitions. Okay, so let us consider that there are two vectors u and v. Okay, all of you know what is a vector. I will not explain again. So you can see over here there is a vector u and there is a vector v. Okay, what is a Hamming distance? Hamming distance, which is denoted as d into bracket u comma v, is the number of places where the two vectors differ. Okay, Hamming distance is a number of places, total number of places where these two vectors will differ. Okay, for example, let us go directly to an example. If we use a binary vector u, which is having 1 0 1 0 1 0 1 0, and vector v is what? 1 0 1 1 1 0 0 0. So I need to find out number of places where these two vectors are differing each other. Over here they are matching, over here they are matching, over here they are matching, over here they are not matching. 0 and 1. Over here they are matching, over here they are matching. 1 and 0 again, this is a place where they are not matching. Okay, so what will be my value of d u comma v is the number of places I am differing. How many number of places I am differing? This is the first one and this is the second one. So this is equal to 2. That is at 4th position and 7th position. So this is your Hamming distance, where you are calculating the number of places where two vectors differ each other. To calculate a Hamming distance, you require both the vectors of similar length. Okay, so both the vectors of similar length. Okay, then only you will be able to find out what is the Hamming distance between two of them. Okay, I hope this Hamming distance concept is clear to you all. Okay, and hope you all are taking down whatever I am delivering over here. Okay, now for a code, one can calculate the Hamming distance between any two distinct code words. Okay, out of these distances, there is something called as a minimum Hamming distance. Okay, there is something called as minimum Hamming distance or minimum distance of C. Okay, so now you have already done about Hamming distance. Now we can also find out the minimum distance of C, which can be written as either d of C or. Okay, now differentiate. There is a difference between a Hamming code, okay, and there is a difference between a minimum Hamming code, okay, minimum distance of C, which is called as d min. Okay, so let us see what is the formula. Okay, if I want to calculate what is the minimum distance, okay, it is nothing but d of C is nothing but minimum distance of vector u comma v, such that u and v belongs to the C and u is not equal to v. Okay, don't worry about this equation and all. I will show you with an example what do you mean by a minimum distance of C, or what is called as d min. We require these concepts in our problems when we are solving. We need to calculate what is the d min. Okay, based on d min we will be able to know whether there is a error present. Okay, we will calculate what is the d min value. Based on d min we will have to know whether the error is present. Second, we will come to know if the error is present, where the error is present. Third, we will come to know if the error is present. For example, if there are error present in 2 bits, okay, how many bits we can replace. It is not compulsory that every time there is an error in 2 bits and we will be able to repair both the bits. sometimes according to the formula, you won't be able to find out both the errors. Okay, you might be able to find out only one error. Okay, so that is been required very much. So for that you need to calculate what is the d mean value. Okay, now look at this definition of d mean. The minimum distance of C is a very important number since it measures the minimum number of errors needed for U to be changed to V. Okay, so minimum number of errors. Okay, so it will calculate, it will try to find out the minimum number of errors needed for vector U to be changed to vector V. Don't get confused still. Okay, I hope you all have understood what is Hamming distance. Very simple. Okay, it's a difference. It is like what you know. It is like a places where two vectors differ. And what is minimum distance of C? It measures the minimum number of errors, okay, needed for vector U to be changed to vector V. Okay, so let's see an example. I've put a simple example. Okay, now this we are trying to differentiate between what is a Hamming distance and what is a minimum Hamming distance. Okay, this is Hamming distance. Now suppose there are two vectors. Okay, vector 1 and vector 2. Okay, so how do we calculate now that vector? What is a Hamming distance? What we have done previously? Previously we were calculating in my previous slide. It was like this is my second vector 1001 and 1101. I've just written it over here. And what we were checking, how many bits are not matching. This bit is not matching and this bit is not matching. That's where we were coming to conclusion that d of u comma v was 2. But there is one more simpler method. We can just XOR both the bits u and v. The moment we XOR both the bits, what we are going to do, what is your XOR function says? If you get 1 and 0, answer will be 1. And if you get 0 and 1, your answer will be 1. Okay. For similar values like 0 and 0, your XOR value will be 0. And for 1 and 1, your XOR value will be 0. Okay. So similarly, I'm trying to XOR my 1 with this 1. I'm getting the answer as 0. Okay. XORing 1 with this 0, I'm getting answer as 1. Similarly, I'm calculating for all other. And then I'm just calculating how many numbers of 1 are present. Okay. The position at which the answer is 1. XOR answer is 1. How many positions are there? 1 and 2. Okay. So that means the Hamming distance of these two vectors is nothing but 2. Okay, one more method I have shown you, a very simple method. You can either compare both the variables or you can directly XOR. Now coming to your minimum Hamming distance. Okay, so it's the smallest Hamming distance between the vectors. Okay, now for example, these vectors are given to you 1, 2, 3 and 4. What I will do is I will try to XOR each and every vector with each other. Okay, and find out what is the Hamming distance, which is the Hamming distance. Okay, so I take my first vector, I XOR it with my second vector. Okay, first vector XOR with my second vector, I am getting as 0, 0, 1. That means what? I will calculate the number of ones. So the Hamming distance between your first and the second value is nothing but 1. Similarly, I will do it with first and third. Okay, that is 0, 1, 0, 1, 0, 1. I'm getting answer as 1, 1, 1. So my minimum, my Hamming distance is 3. Okay, my Hamming distance is 3. Similarly, I'll calculate this with the fourth one. Okay, similarly, I'll calculate this with this. I will calculate this vector with this vector, and finally this vector with this vector. So when I do all these things, I get the Hamming distances. Now, what is the minimum Hamming distance? Minimum Hamming distance is nothing but what is the minimum value, okay, of nothing but 1. That's why hence, okay, hence the minimum Hamming distance d mean is nothing but 1. I hope you all understood what is a Hamming distance and what is a minimum Hamming distance, and how do we calculate what is the Hamming distance and what is the minimum Hamming distance. So minimum Hamming distance is nothing but it is the number of for example, according to your previous calculation, measures the number of errors needed for u to be changed to v. So we have seen the example over here. So I will first XOR and try to find out what is the Hamming distance of all the vectors, and whichever is the minimum, that becomes my minimum Hamming distance. Okay, so this is all about your Hamming distance and minimum Hamming distance. Okay, anybody is having any doubt in your Hamming distance and minimum Hamming distance? Before coming to that, let us learn very two important properties of your minimum Hamming distance. Okay, now these two properties are very important as we are going to use it in our problem. Okay, suppose that there are d errors in the received code word. Okay, now for example, code word received was 1011. Okay, and there are, say example, 1, 2, 3 errors. 3 errors are there. So if there are D errors in the received keyword, let us consider D as 3. So if there are D errors in the received keyword, then provided that D is less than equal to D mean minus 1, okay, we shall, if your this condition satisfies, then we will be able to detect the error, and certainly we are with certainty, and the received code word is not valued. Okay, and we can conclude that whatever we have received is not valued. Okay, so keep this in mind. Suppose there are D errors which are found. First we have to check for this condition whether the D is less than equal to D mean minus 1 or not. If this condition is satisfying, then only we will be able to detect the error properly. If this condition is not satisfying, we won't be able to detect the error in the your received code word. Okay, so this is your first condition. All of you please write down this first condition. And second condition, let us say that there are T errors which are occurred in your received keyword. Okay, then provided 2T plus 1 is less than equal to D mean odd, and 2T plus 2 less than equal to D mean even, we shall not be able to establish that the received word is not valued. Okay, so if this particular condition satisfied, D mean odd is nothing but if your value of, for example, in your earlier value, you have got the value as 1. Okay, in some problem you have got the value as D mean value as 3. So 3 is your D mean odd. If your D mean value is odd, you are going to look at this number only. Okay, this equation only. If your D mean value is even, you are going to look at this equation only. So if there are T errors found out, and if this particular condition satisfies, then we will be able to find out the error also, and also we will be able to correct the error. Okay, so we will be able to find out the error and also correct the error. So we shall be able to generate the original correct code word. So this particular property number 1, okay, will only check if we are able to detect the error. The moment we are able to detect the error, we have to go to step 2 to check what is 2T plus 1, whether D mean is odd. Based upon D mean is odd or D mean is even, we will calculate this, and if this condition satisfies, okay, then we will be able to also correct the error. Okay, so how do we do it? We will see it in the problem. You don't need to worry about it. How do you do it? We will see it in the problem. So as of now, you should know what is a code word. Okay, what is the information bit, what is K, what is R, what is N. Okay, how is the formula? Okay, what is a code word? Okay, then you need to know what is the Hamming distance. Okay, you need to know how to calculate the Hamming distance, how to calculate the minimum Hamming distance, and what are the property of minimum Hamming distance. Okay, so before going further, I just want you all to, I'm just keeping this forum open for 2 minutes if you have any difficulties in the concept that I have taught till now. I've come back to the chat, so if anybody is having any doubt, please put it in the chat. There are 49 students in the class today. If you have understood the concept, please say yes. If you have not understood the concept, please type your query in the chat box, or you can unmute your mic, because this is very important. Based on this, we are going to go further and do the remaining problems. So can you explain the minimum Hamming distance again? Okay, fine. Anybody is having any other doubt? Because I won't be coming back to the chat screen. Pratibha, anybody else is having? Am I audible to you all? Am I audible to you all? I had lost connection in between. Okay, so anybody is having any doubt? No doubt, but when you teach how to solve the problem, please make the video. Not possible. I'm not going to make any video henceforth. Now only you all are 48, 49 students, and you'll expect me to make a video and teach you all. And that becomes a ready-made. Okay, we'll see later. Let me explain the concept first, and then we will see how it goes. Okay, let it be. We'll see. No worries about it. Okay, so I will just explain what is the minimum Hamming distance question asked by Pratibha. Okay, how to calculate the minimum Hamming distance? Very simple. Now, for example, there are 4 vectors given to you all: 0, 1, 0, 1, 0, 1, 1, 0, 1, 1, 1, 0, 1, and 1, 1, 1. Okay, I'm just taking this vector that is given to you all. So what I will do is I will try to find out first the Hamming distance in between all these vectors, all possible vectors. I'm trying to find out Hamming distance. You know how to find out the Hamming distance? I will just XOR both the bits and calculate the number of ones. Okay, and that become my Hamming distance. Okay, so that is your Hamming distance. So in this first case, I'm getting Hamming distance as 1. Second case, I'm getting Hamming distance as 3. Third case, I'm getting Hamming distance as 2. Fourth case, I'm getting Hamming distance as 2. Fifth case, I'm getting Hamming distance as 1. Fifth case, again, sixth case, I'm getting Hamming distance as 1. So what I'll do now, I will compare all this Hamming distance and check which is the minimum Hamming distance that can be calculated. So that is nothing but your minimum Hamming distance. Okay. So this is how you calculate your minimum Hamming distance. If you go by definition, it measures the minimum number of error needed for you to be changed to V. Okay. So there is an example that is shown over here, a code of length n with m code words and with a minimum distance of d mean can be written in this form: n comma m comma d code. It is called as n comma m comma d code. Okay, so with the n length of code as n, okay, code word. This n is nothing but the length of the code word. M is the actual code words, how many code words that are present, and d is nothing but the distance, that is your minimum distance. We can write this as n comma m comma d code. For example, now let's see the binary repetition code, that is 000 and 111. Okay, if I want to represent this in the form of your n comma m comma d, how do you represent? N is nothing but the length of the code. Now this is your single code, code number 1, code number 2. What is the length of the code? 1, 2, 3. So I have written the length of the code as 3. Okay. Second is your m. M is what? How many messages are there? This is your first message. This is your second message. So 2 messages. So I have written 2 over here. Okay. And d is nothing but the minimum distance. Okay. When I calculate the minimum distance over here. How many? So if you XOR with this. So if you XOR here 1, 2, and 3. What values do you get? I get the value as 1, 1, and 1. Calculate the number of ones. How many number of ones are there? 3. So your d mean value will be 3. Okay, d mean value for this equation is 3. That is written over here. That is 3. Anybody is having any doubt? I felt like somebody has opened the microphone. Anybody is having any doubt? They can ask me. Okay, this is just a simple explanation of what is n, what is m, and what is your d mean. How to calculate it. Okay. Now error correction. How can we do error correction? So error correction, as you know, I have explained you previously. We can either tell the sender to send the whole data again if there is any error that is encountered at the receiver end, or receiver by using some error correcting codes like block codes, cyclic codes, then other linear codes. He can using this error correcting method, he can automatically correct the error. So this is how you can handle the error correction. So whenever you are sending anything, how does the error comes into a picture? This is a very simple example. There is a message, encoder will code and he will send it on the channel where it will go to the receiver. Now on the channel there is a lot of noise. Because of noise, the noise gets added to your actual information and your actual information gets altered. This I have already told you previously. So the bits at last what you are transferring is nothing but bits, zeros and one in the form of electrical signals, right? So these zeros and ones might get altered. In place of 1, you might get 0. In place of 0, you might get 1. I'm giving you a very small example of 0 and 1. But actual bit of data, when you are sending it, is in the form of long stream. Okay, it may be 512 bits or 1024 bits. So there might be alteration in the message. So how do we control that? One method is what? Send the whole data again. Or second, using the error correcting codes, we need to correct it at the receiver end. Okay. So now let's learn something called as, what do you mean by binary code? Okay, what is binary, tertiary, and query code? Binary code is nothing but whenever you are representing any alphabet in the form of binary, that is 0 or 1. Okay, it is called as a binary bits 0 and 1. It is called as a binary code. Okay, a code that uses a sequence of 3 symbols. Okay, a code that is using a sequence of 3 symbols, often represented as integer mod 3, is called as a ternary code. Okay, it is called as a ternary code. And in general, a code that uses an alphabet consisting of q symbols, it is called as query code. Okay, so whenever there is only binary bits represented to represent binary bits used, that is zeros and one to represent the alphabet, it is called as binary code. Third one, if we are using a three symbol sequence of three symbols to represent, then it will be called as ternary code. And if you are using n symbols or q symbols, it will be called as a query code. This is just for a definition purpose. So your n is called as a code word, as I have told you previously. K is your information bit and R is your redundant bit. So we can either call your n as a code word, or you can call it as a code vector. Okay. For example, in the binary repetition code, where each symbol is repeated 3 times. Okay. In the previous example where you have seen over here, I have repeated each symbol 3 times. 0, 0, 0. I have represented A as 0, 0, 0, B as 1, 1, 1. Okay. So in that case, what will happen? So for example, in the binary repetition code, where each symbol is repeated 3 times, the alphabet is set. Okay, the alphabet is set A as 0 and 1, and the code is what? 0, 0, 0, 1, 1, 1. So A will be repeated 0, 0, 0 and 1, 1, 1. Okay, so this is just an example of a code word. What do you mean by code word? Okay, redundancy bit. If you want to calculate what is a redundancy bit, we first should know what are my actual data bits. So this is your whole data bit, which you are sending from sender to a receiver. This is a whole bit. Okay, so only this part is your actual information. That is nothing but K, what we were talking about. N equals K plus R, and this is nothing but your redundancy bit that we are adding. So your whole N, so this is whole represented as N, which is nothing but your K plus your redundant bits. Okay, this is just explained again so that you don't forget. Coming back to the block code, okay, we were on a block code, then we understood what is Hamming distance, what is minimum Hamming distance, okay. Then we learned some basic concept, what is Q binary, what is Q array and all those things. Now we are coming back to the code word, okay. As all of you know, your code word is nothing but N equals K plus R, okay. N equals K plus R. So there are M valid code words. As you know, M is nothing but the number of code words that are present. Okay. So M here will be nothing but number of code words. So total number of code words that are present. Okay. And code word is what? Code word is nothing but your N equals K plus R. Okay. So now if you understand, N is your K plus R. R is your redundant bit. So what is your A? A is nothing but your actual information. Okay. So if you have only your actual information, it does not make it as a code word. To make it as a code word, I have to add a redundant bits. Okay. So I have just implemented over here. This A is nothing but your uncoded part. That is nothing but this K. So that I will represent as A1, A2, A3, A4, A5 till AK. Do not worry about it. I am just explaining it. You will be very much clear when we solve a problem. So don't get confused. As of now, whatever things I am telling you to, just keep it in mind. Only those things you keep it in mind. Okay. So the generation of a block code. So basically your block code will start with your actual number of bits, that is K, followed by your R. R is nothing but redundant bits. So when you are solving the redundant bits, we take this redundant bit as your identity matrix. All of you know what is identity matrix. If I want to generate an identity matrix of 2 by 2, let us take the smallest example, identity matrix. It will be 1, 0, 0, 1. If it is a 3 by 3 identity matrix, what do we take? It is 1, 0, 0, 0, 1, 0 and 0, 0, 1. So this is your identity matrix. So usually when we solve this type of problem using block code, we take our redundant bits as your identity bits, okay, as your identity matrix. Okay, so the generation of the block code starts with the selection of the number of R bits. R bits are nothing but redundant bits. So this over here are nothing but your redundant bits to be added thereafter with the specifications of S. So this is nothing but your actual value K. K is nothing but your actual information, and this is nothing but your R. So when K is combined with R, I get something which is called as a code word, which is named as H. Okay, over here in the example in your textbook, your K plus R, that is nothing but the formula, is named as H. So H will be your actual information in the form of a matrix. Okay. Now H transpose. What is H transpose? H transpose. All of you know what is a transpose of any this thing. So if I want to calculate transpose of this, what I will have, what I will do, I will convert my rows into columns. Okay, and my rows all my rows will get converted into columns. So that will be my H transpose. So if I convert my rows into column, what will come over here? So it will be like H11, H12 till H1K, followed by this 1, 0, 0, all these things. So when I do my transpose, I get the same thing. See, H11, H12, H1K, 1, 0, 0, 0 continuously. So this is my H transpose matrix. Do not get confused. Just keep in mind what is your H matrix. H matrix is your K plus R. Okay, H transpose, all of you know how to make transpose, convert the rows into columns. Okay. Then what is your G? G is nothing but your generator matrix. Why do we require this generator matrix is only because, for example, if the uncoded word, okay, there, for example, if the uncoded word is nothing but your K. For example, if the K is not given to you, for example, this K, in this case, we have taken uncoded word as A. Okay, uncoded word is nothing but A. When we add this A with R, that time only it will become a code word. Okay, when we add this A plus R, then only it will become as code word. Apart from that, if R is not identified, it is called as an uncoded word. Okay, uncoded word A. To generate the code word T, we require, okay, from uncoded word, we require a generator matrix. Okay, so what is generator matrix? Just write this. Generator matrix is nothing but your identity matrix. Okay, identity matrix multiplied by H transpose. Okay, your identity matrix multiplied by H transpose. Okay, so just keep this in mind. Okay, so generator matrix is nothing but your identity matrix multiplied by H transpose. Okay, just give me a second. Yeah. Sorry for the interruption. So your G is nothing but a generator matrix that is required. Okay, if you have a uncoded word, how to get an uncoded word? Okay, how to convert your uncoded word into your code word? That is nothing but your final code word. So to do that, we require generator matrix whose formula is identity matrix, that is over here, and this is nothing but your H transpose. H we have already seen in the previous example. Okay, so your H is nothing but if you see your previous example. Okay, so your H is nothing but your K is nothing but what is given to you. Okay, multiplied by your identity matrix. Okay, so we can always write it in that form. So it is basically your H is nothing but, so write these formulas, whatever I'm writing over here, as your H is nothing but your smaller H, that is nothing but your information. This is nothing but your K multiplied by identity matrix. Identity matrix is nothing but 1001, 1001, 0011. So if you have the G matrix, I can easily calculate what is my H matrix. And if a H matrix is given to me, I can easily calculate what is my G matrix. Okay, so these two formulas you have to write. Please keep it in mind. G equals your G, that is your generator matrix, equals identity matrix into H transpose. Okay, and your H is equal to your smaller H, that is nothing but the information, multiplied by your identity matrix. Please write this formula. We will use this when we solve our problem. Okay, so these two things are very important. So we have seen what is a H what is your H matrix, what is your G matrix, and how we can find out G matrix from H matrix and H matrix from G matrix. Okay, so T is basically your total code word. So how we have written over here is nothing but T is your code word. Okay, so I will write the formula over here for you all. Do not get confused. So when we are doing this, we are always taking this formula. T equals, okay, so we have written this formula properly. So the generator matrix G having been formed, the code word T corresponds to the uncoded A along with your G. So T will be equal to A into G, where A is your uncoded part and G is your coded matrix. Okay, so what is G? This G is nothing but your I into H transpose. Okay, so just keep this thing into mind. Anybody is having any difficulties till what we have done till now? Let us jump to the problem, and from this problem you will be easily able to find out using the formulas. Okay, so it will be very easy for you all to find out using this formula. And now what is basically asked in the question paper is such type of questions. Okay, now see, this is a question that was asked in one of the question paper. I have taken from there only. Okay, the generator matrix of 6 by 3 block code is given below. Okay, generator matrix is given to you below. Okay, so you know what is a generator matrix. Your generator matrix is nothing but your identity matrix into H transpose. Okay, generator matrix is given below. What is told? Find all the code vectors of this block code. So there will be so many codes, right? So in this particular message there will be so many code vectors which are present. How many errors can be this scheme can correct? Okay, so that is nothing but the properties of your d mean. Okay, so that properties what we have learned, property number 1, property number 2, that we will introduce over here. Okay, thirdly we will find out, we will introduce a 1-bit error, okay, in the first bit, okay, of the data which we are sending. Okay, and we will find out what is the error syndrome. Don't get confused. Okay, there are altogether 3 parts in this. First we have to find out all the code vectors or all the code words. We can say code vectors also, we can say code words also. How many errors can this scheme correct is the second question. And third one is, we will purposely introduce a 1-bit error while sending the data, and we will check whether we are able to detect where the error is present and whether we are able to correct that error. Okay, so that is my question number 3. This question was asked in one of your question paper. I have picked the question from the question paper. All of you please take down this question. All of you please take down this question so that we can solve it step by step. All of you please take down this question. We will definitely go till 3:15 because I will require minimum 15-20 minutes to finish this problem. I hope everybody has taken. Before I go further, I want, if anybody is having any doubt, I have come back to the screen again. Okay, I have come back to your chat again. Please, if you have any difficulty, please let me know. Ask me right now. I'm giving you 1 minute of time. Otherwise, we can proceed further. Yeah, Vedangi, I will definitely go very slow to the problem. That's why I've taken more 15 minutes today. No worries. I will see to it that each and every one of you understand this problem. Do not worry about it. No one is having any doubt? No doubts? Anchita, no doubt? Anchita, Ashwini, Eldrich, Krupashri, Melroy. Can you explain what is T? Okay. Priti, yeah, I'll explain. No worries. No worries. I'll explain. Just ask your queries, whatever you have queries. Just don't wait that I will call your name and then you'll ask me the queries. Somdat, Vedangi. Okay, can you explain what is T? I missed that part. Okay. Now, let me go to the presentation, and as there are no doubts, I will continue with my problem. I hope everybody, she was here. I hope everybody has understood the concept till now. Okay. Now, let me explain to Ruchika what is T. Do not get confused. This is just an abbreviation. Okay. Let me write here. For anyone who is any doubt. What was our initial formula? N equals K plus R. What was N? N was my code word. N was my code word. T is nothing but T is my code word. So T is as good as your N. Okay. T is as good as your N. Okay. K is as good as your A. G is your generator matrix, which we have calculated with your redundant bits. How we have calculated it? It is identity matrix into H transpose. Okay, Ruchika, is it clear to you? We will see as we go through the problem, but you should know what is T, what is A, what is G, what is H transpose. All these abbreviations you should know. remember the formula. What is H? What is G? H is your actual data A, okay, that is smaller h into identity matrix, and G is your identity matrix into H transpose. Given H, I can easily find out what is G. Given G, I can find out H. In the current problem, what is given to us is G. Okay. Now, what is G is 6, 3. How is your block code represented? Block code is represented as N, K. What is the value of N? N value is 6. K value as 3. What is the formula? N equals K plus R. N value is given to us. K value is given to us. And I found out what is R. R is nothing but 6 minus 3. That is 3. So my redundant bits are of 3 bit long. Okay. What is my G? G is always written as identity bits into H transpose. Okay. G is my identity bit into H transpose. Okay. So now this H is nothing but we are searching for this repetitive bits R. How many bits is the remainder? Remainder is of 3 bits. So these 3 bits are your H transpose. Okay. And these 3 bits are your identity matrix. You can see 1 0 0 0 1 0 0 0 1. This is your identity matrix. Same thing is explained again over here. Given G to you, you know what is G. A block code is given to you 6, 3. N is equal to 6. K is equal to 3. N is equals 3 plus R. 6 equals 3 plus R. R value is 3. So that means we know that our remainder, okay, our remainder is 3 bits. Okay. And the moment my remainder is 3 bits, okay, so now you know 6 equals 3 plus 3, which you already found out. This is your A. This is your A. That is nothing but your uncoded data. Okay. So this is your A, that is uncoded data. What is the length of your uncoded data? We know that the length of the uncoded data is 3. Okay. So that's why I name my uncoded data A as 3 bits. A1, A2, A3. Okay. So did you all find out how I have calculated my remainder? I know my remainder is 3 from this formula. Now I need to find out what is my uncoded data. My uncoded data is of 3 bit long. How do I name that uncoded data? I name that uncoded data as A1, A2, A3. Okay. Now your formula will come into picture. Okay. Now your formula is going to come into picture. What is being told to us? What is now our question number 1? Question number 1 over here is nothing but in this problem. Question number 1 is find all the code words or find all the code vectors of this code, block code. Okay. Find all the code words or code vector. Over here, I have told you what is a code vector. Code vector is nothing but T. What is the formula to calculate your T code words? Okay, my question number 1 is to calculate code words. So I am solving my question number 1 over here. Okay, I am solving my question number 1. Okay, so to solve it, so T is nothing but total number of code words. So code words is nothing but A into G, right? This is the formula which I have told you. T equals A into G. A value I have assumed as A1, A2 and A3. Okay. And G value is already provided to me. So I will directly substitute in the formula T equals A into G. Okay. Code word T is A into G. A value I have taken as A1, A2, A3. Okay. A1, A2, A3. And G value is already provided to me. Okay. I will do matrix multiplication. I will do matrix multiplication. Okay. What I will do now? How I'll do matrix? I hope all of you know how to multiply rows and columns. Okay. So I'll multiply this A1 with this 1. What is remaining? A1 into 1 is A1. A2 into 0 is 0. A3 into 0 is 0. So what is my value that is remaining? Only A1. So I have written A1 over here. Okay. Then again I will do A1 into 0. I'm getting as 0. A2 into 1. I'm getting as A2. A3 into 0. I'm getting as 0. So what is remaining? Only A2. So that is nothing but A2. Similarly, I will multiply A3. Okay. So similarly, I will multiply A1 with 0, A2 with 0 and A3 with 1. What is remaining? with 1. Correct? So I've got A1, A2, A3. Clear? Okay. Let me come back to the same slide. Now I have to multiply. Now I have to multiply my A1 to this. So already I have done for column 1, column 2, column 3. So now I'm going for this particular column. Okay. So I will multiply this, this, and this. So what is remaining now? A1 and A3. So A1 XOR A3. Okay. When I multiply this A1 from next, A1 into 1 is A1, A2 into 1 is A2, A3 into 1 is A3. So A1 XOR A2 XOR A3. Okay. And last one, I will multiply A1 with 0, multiply A2 with 1, okay, and multiply A3 with 1. What is remaining? A1 into 0 is 0. So A2 XOR A3. Okay. So from this, we have generated our T as this is your, this value is what? This value is nothing but your K value that we have taken A in this example as uncoded word. Okay. And these are your 3-bit redundant terms, digits. Okay. So I have named this as C1. I have named this as C2. I have named this as C3. Same thing I have written over here. C1 is A1 plus A1 XOR A3. C2 is A1 XOR A2 XOR A3. And C3 is A2 XOR A3. Okay. So this is just a general multiplication. Okay. A values I have taken as A1, A2, A3. G value is already provided to me. I have just do matrix multiplication and find out what is my T. Okay. I have not found out now all the codes. Codes I will find out in the further steps. But as of now, I have just created an equation as in how I'm going to find out my codes. Okay. So I just want to know from you all if you have understood till here. Did you all understand till here? I'm back on the screen. Vedangi, did you understand what I have done till here? How I have calculated T? Sheena has understood. Amatya has understood. Vedangi has understood. Okay. Anybody else? Anybody else is having any error? How you have done matrix multiplication? What is the formula of T? T equals A into G. G is already provided to us. A is already given. Anchita also got. I want to know from few more students if they have any difficulty. Sweeney, did you understand what we have done over here? Sweeney, have you understood what we have done till here? Can we go to the next step of calculating what is my code word? Okay. Russell, any doubt in this? Russell, did you understand what we have done till here? Russell? Next, Len, have you understood what, have you followed till what we have done over here? Because next part is a little bit complicated. Okay, great. So I will go further to the slides. Okay. I will go further to the slides. Okay. Now, how to go about, now we need to calculate what is our C1, C2 and C3. We need to calculate what is our C1. We need to calculate what is our C2. What is we need to calculate our C3. We know what is the formula of C1. We know what is the formula of C2. We know what is the formula of C3. Okay. Now, what was the actual length of the message? Okay. N equals K plus R. We have calculated. Know what is the actual length of the message. Your actual information bits. Your actual information bits was nothing but N was 6. Okay. And K value was given as 3. So because of which we have found out what is the value of R. Now we know that our actual information in our language, we have called this as, this is nothing but your actual information K. Okay. So if there is K, if there are K bits, how many total code words will be present? There will be total 2 raised to K code words will be present. What is 2 raised to K? 2 raised to 3. So there has to be how many code words that has to be present? 2 raised to 3 is nothing but 8. So my first question which was asked to me, calculate all the code words that are present. Answer is over here only. How many code words are there? 8 code words are there. That much I am clear about. Okay. Now I need to calculate what are these code words based on the form that we have got over here. Okay. Now, how many, now what is this K? The total number of bits that are present in your actual information is nothing but 3. Okay. So total number of bits that are present in your actual information is nothing but 3. Okay. So we have to write down the values. Okay. Now 3 means what? Your binary can be represented either in the form of 0 or 1. So what I will do is, don't look at the right hand side part. Okay, just look at this part. Just look at this part, what we have done. Okay, so I have written all combinations of 3. I have written all. So this is binary 0, binary 1, binary 2, 3, 4, 5, 6, 7. Okay, so I have written all the combinations of the number, because we know that the value of k equals 3. Okay, and in the binary form we can write it either in the form of 0 or 1. Okay, we have seen this previously. If I had shown you one example, how do we represent a was represented as 000, okay, or 001. Okay, so your message is over here. Whatever you are sending the message will be either in the form of all this from 0 to 7. Okay, now what do we need to calculate? We need to calculate what is A1, A2, A3 and C1, C2, C3, which will make our code word, which I have already told you in my previous slide. So this T is nothing but my code word. So based on the values, okay, based on this left hand side values, I will calculate what is my code word. So what is A2, A3? So let me write here what is C1. What was C1? Can you tell me what was C1 in the previous example? C1 was A1 XOR A3. Okay. C1 was A1 XOR A3. Okay, so I'll just write down here A1 XOR A3. Okay, C2 was very simple. A1 XOR A2 XOR A3, and C3 was A2 XOR A3. I hope all of you are following this. I have written it from the previous slide only. I will take a lot of time over here. Don't worry. You can write down simultaneously when I am explaining you. Okay. So initially what will happen? A1, A2 and A3 are 0. Okay. So A1 value is 0. A2 value is, so I'm taking as it is. What is the A1 value? 0. A2 value is 0. A3 value is 0. So A2 value is 0. A3 value is 0. So the same thing I've written over here. C1. C1 is what? A1 XOR A3. Okay, what is A1? A1 is 0. 0 XOR with 0 will be what? Answer will be always 0. Similarly for A1 XOR A2 XOR A3 for C2. A1 XOR A2 is what? 0. A2 XOR A3 is what? Again 0 XOR 0 will be equal to 0. So C2 will be 0. Similarly you will get C3 also 0. So always remember, for 000, you will get all the code words as 0 only. That's why we never consider this value 0 anywhere. But while writing, because it is 2 raised to 8, okay, it is 2 raised to 8 means what? 2 raised to 3. 2 raised to 3 means nothing but there are how many code words altogether? 8 code words. So one of the code word is this 000 and 000. Usually we never send this code word, but we consider it as one of the code word. Okay. Now let me go to the, now let me go to the second part. Okay. Now the second is what? 0, 0 and 1. So what is the value of A? A1 is 0, A2 is 1, A3 is 1. Oh, sorry, A2 is 0, A3 is 1. Now, C1 is what? Your C1 is nothing but A1 XOR A3. What is your A1? Your A1 is nothing but 0 and A3 is nothing but 1. So 0 XOR 1 is what? Is your 1. Similarly, A1 for C2, A1 XOR A2 XOR A3. Let's see. A1 XOR A2. 0 XOR 0 is what? 0. But it is A2 again is XORed with A3. So 0 XORed 1 is what? 1. So your answer over here is 1. Okay. C3. C3 is A2 XORed A3. Okay. C3 is A2 XORed A3. So what is your A2 is 0. XOR is A3 is what? 1. So 0 XORed with 1, your answer will be 1. Okay. So this is how you have to find out all the code words. So this will be our, so all this will be our 8 code words that we are finding. So these code words are nothing but, if you in our actual language where we were writing n equals k plus r, this code word will be this n, total number of n, 8 code words. Okay. And each of this, okay, will be nothing but t. T over here in the example we have taken n as t. So this t are total 8 code words which we are finding out. Okay. So I'm giving you 5 minutes of time. The way I have done it for 000 and 001, I want you all to calculate all the code words, all 8 code words for 2, 3, 4, 5, 6 and 7. Please do it. I'm giving you 2 minutes time. Still there are 10 minutes with me. I know we can finish it off. I will ask anyone to show me the answer. You all can just click the photo and send it to me on WhatsApp. I will check it right now. I will tell anybody to show me the answers. Show me the answer for our question number 1. That is to find out the total code words. That is nothing but T. So T is nothing but your A into G. Okay, G is already provided to us. A, we have identified how many bits of A is nothing but 3. So we have taken A as A1, A2 and A3. This way we are calculating what is the total code words that are present in the data that is given to you. Manish, can you tell me? Can you just send me a photograph of what you have done? I will verify. You can send it on the group only. You can send it on the group directly so that I can check and tell you what is the answer. Manish, are you there? Manish Borkar, are you there? Let's not waste time. A lot of problem is remaining. Okay. Something I've got. No. Yes, sir. So have you done? Who has done? Please send me the answer on the group. Cryptography and coding theory group. Please send the answer. Please send the answer on the group for reference. Okay, somebody has sent the answer on the group. Okay, just check if all of you are getting the same answer. Let me check also with my answer that I'm getting over here. Let us check whether it is correct. So first one is 0, second one is 0, 0, 1, 1, 1, 1. Third one is 0, 1, 0, 0, 1, 1. Fourth one is 0, 1, 1, 1, 0, 0. Correct. Fifth one is 1, 0, 0. Okay. 0, 0, 1. Correct. Sixth one is 1, 1, 0, 1, 0, 1, 1, 1, 0, 1, 0, 1. And seventh one is 1, 1, 1, 0, 1, 0. Correct. So I think whoever has sent the answer on this group is correct. All of you all please verify if you are getting the same answer. And that means you have found out the answer for your question number 1. That is how many code words, find out all the code words that are present. Now what is our question number 2? Our question number 2 is what? How many errors this scheme can correct? For that we have to go to the d-mean property now. Now for that d-mean property I need to calculate what is my d-mean. How have you calculated the d-means of the codes? Okay, I have already XORed the function over here. Okay, I will already XOR the function. So over here, I will just check the number of 1. Always ignore the first one. So 0, 0, 0, we will ignore. We will not calculate the d-mean for over here. So let us calculate the Hamming distance first. Before calculating the minimum Hamming distance, let us calculate Hamming distance. To calculate Hamming distance, I have already XORed the values over here. So I will just calculate how many ones are present. So 1, 2, 3, 4. Okay, so I have written the Hamming distance over here. Again, I will calculate the number of ones. 1, 2, 3. So number of ones are 3 over here. Over here also 1, 2, 3. So I'll just calculate the number of ones, that is 3. That is again 1, 2, 3. Okay, I'll calculate the number of ones, which is 3. Okay, over here 1, 2, 3. Okay, this is also 3. Here, how many number of ones are there? 1, 2, 3, 4. Okay, so 1, 2, 3, 4. Number of ones are 4. Over here 1, 2, 3, 4. Number of ones are 4. Now I will compare and check which is the minimum distance. Okay, over here the minimum distance is nothing but 3. That's why, therefore, you don't need to do this. This is a very complicated method which is shown over here. This is one of the most simplest method of calculating d-mean. Okay, so d-mean over here is nothing but 3 here. Okay, and as you see, this 3 is nothing but an odd value. Okay, so this 3 is nothing but odd value. So let us move towards the next this thing. Then let us move towards the next step where we are calculating now error detection and error correction. How many errors can be calculated? For that, first property of d-mean has to be used. Okay, what is the first property of d-mean? First property of d-mean is nothing but, so we have calculated the d-mean value as 3. Okay, now the first property of d-mean is nothing but over here. So your d should be less than equal to d-mean minus 1. Okay, d-mean value we have already got. What is the d-mean value? 3. What is 3 minus 1? 2. Okay, so 3 minus 1 is nothing but 2. Therefore, it can detect up to 2 errors. So error detection is done. Okay, it should always, and D is 3 minus 1, which is equal to 2. Therefore, it can detect 2 errors. Now let us see how many errors it can correct. Let us solve our second question. How many errors it can correct? To find out the error, how many errors to correct, we have to go to the second property of D min. Okay, I will go backward if you want me to go back and check what is the second property. Okay, so this is your second property. Okay, 2t plus 1 should be less than equal to d min odd, and 2t plus 2 for less than equal to d min even. So now we have to follow 2t plus 1 less than equal to d min odd, because 3, the value of d min that you have got is odd value. Okay, the value of d min that you have got is your odd value. Okay, so what I will do over here, so d min is nothing but your odd value. Okay, so d min is 3. So I will use 2t plus 1 equals your d min. Okay, 2t plus 1 equals your d min. So 2t plus 1, you know what is the value of d min? D min is 3. So when I calculate t, so t will be over here. If you want me to show this expression, it will be t will be over here. It will be 3 minus 1 divided by 2. Okay, 3 minus 1 is 2. 2 divided by 2, answer is nothing but 1. Okay, so that means it can correct bit up to 1 error. Okay, so our question number 2, which was asked for this particular problem, you need to find out how many error can be detected, okay, and how many errors can be corrected. This we have calculated based on 2 properties of our d min. How we have calculated d min? You all know how we have calculated d min using this previous method. We are just calculating the number of ones in each row. For each code word, number of ones. Compare it, whichever is the smallest. Now 3 and 4 values are there. 3 and 4, correct? So which is the smallest value out of 3 and 4? 3. So d min value is 3. Okay, using that d min value, I am doing error detection, error correction. Okay, so my second question also is answered. What is my third question now? My third question, they are telling me to introduce a 1-bit error in any of the code word. Now we have calculated altogether 8 code words, correct? Over here we have calculated altogether 8 code words, except for the first one. If it is 000, we will never transmit that. So we will transmit the remaining one. So the next what it is telling is, out of the 7 this thing. So this I'm going to send now. I have already generated a code word. No, I'm going to send it to the receiver. So while sending it to the receiver, what it is telling is make any 1-bit error, because from the next slide we came to know that using this particular method we can find out only error up to 1 bit. Okay, so if I make 2-bit error, it won't be able to correct it. Okay, it will able to correct only 1-bit error. So while sending any of this, what I will do is I will make a 1-bit error and I will send it to the user, any of the code word. Okay, any of the code word which I am sending, I will send by using an error. So what I will do is I will send this code word. Okay, 01110. Okay, remember this, please write down which code word I am sending. Any of the code word, you can use any of the code word, but only when you are sending any of the code word, make a 1-bit error. While sending, make a 1-bit error and try to see if that error is being rectified at the receiver or not. Okay, so I am sending this 3 data 011100. Okay, this I am sending. Okay, this is the thing which I am sending, the same one, 011100. But what I am doing now, I am doing a 1-bit error. So 1-bit error, in place of this 0, I am putting it as 1. Rest everything remains the same. So this is your message number 3, okay, that I have shown from the diagram. So I am keeping everything same, only while receiving there is a 1-bit error. 0 has been converted to 1. Let's see whether we are able to find out the error syndrome. What is our question number 3? In our question number 3, it is clearly told to us to introduce a 1-bit error, which we have already introduced, okay, and find out the error syndrome. Simple. There is a very simple formula to find out error syndrome. Very simple formula. Error syndrome formula is H into R transpose. H into R transpose. Okay, H into R transpose. I hope you all have understood the step number 2 that we have done. Okay, now for this question number 3, we are using error syndrome. Do we have this H with us? We don't have H, because what was provided to us was G. Okay, now I have already told you what is the formula for G. G is nothing but your identity into H transpose. What is your H? H is nothing but your H into identity matrix. Okay, so can I generate my G, H from G? Yes, I can generate. So initially my H is nothing but my what? transpose, I have to convert back to H. So if I want to transpose, if I want to convert my H transpose to my H, what I basically do when I convert my H to H transpose, convert rows to columns, correct? Over here to ulta, what I will do, convert column to rows. Okay, so as G is provided to you, we know this part of the G is your identity matrix, okay, which will go as it is on the right hand side over here. Okay, and this is your H transpose. Okay, so rows and columns. So what was there actually? What was 101 was your row, which is converted to column. So what I will do, just ulta of it. So I will just do ulta. So I will convert this into my column. So what I have done, 101 I have written over here. Okay, 111 I have written over here. Okay, and 011 I have written over here. I hope it is very much clear and very much simpler. Okay, so I can generate my H from R. Okay, I can generate from H from G. Okay, and this remaining part is nothing but the identity matrix of 3 by 3. So I have already calculated H. R transpose. What will be my R transpose? R is nothing but a bit which is received. So I have to convert the row into column. So my R transpose will be, just my row will be converted to column. So it will, the same thing I have written over here. Your error syndrome S can be calculated as, your error syndrome S can be calculated as, this is your H, this is your R, try this to this. 1 into 1 is 1. Okay, then XORed with 0 into 1. 0 into 1 is what? 0. XORed with 1 into 1. 1 into 1 is 1. Again 1 into 1. 1 into 1 is 1. Again 0 into 0. 0 into 0 is 0. And last one, 0 into 0 is 0. Similarly, I will do for the second row and third row. When I do for the second row and third row, I get these values. Okay, it is just a sheer multiplication. Now I'll do XOR. Okay, 1 XORed with 0 is what? 1. 1 XORed with 1 is what? 0. 0 XORed with 1 is what? 1. 1 XORed with 0 is what? 1. 1 XORed with 0 is what? 1. So I'm getting answer as 1. Second, 1 XORed is with 1 is what? 0. 0 XORed with 1 is what? 1. 1 XORed with 0 is what? 1. 1 XORed with 0 is what? 1. 1 XORed with 0 is what? 1. So I'm getting answer as 1. 0 XORed with 1 is what? 1. 1 XORed with 1 is 0. 0 XORed with 0, 0. 0 XORed with 0, 0. 0 XORed with 0, 0. Your answer is 1, 1, 0. What I will do now, I will just compare this answer with this H. At which position can you see these bits are same? 1, 1, 0. This is 1, 1, 0, right? So in which position over here can you see that 1, 1, 0? It is present in the first position. That means the error is present in the first bit, and I will replace my first one with 0. Okay, very simple. I will just do this. So error answer, I have compared my answer, okay, from here. Okay, I have compared it to the H and check which of the row over there is present similar to this 1, 1, 0. That is nothing but the first. That means the error is present in the first bit. So I can correct that error. My 1 is corrected to 0. Okay, so this is how you basically, I have also got the question answer of my third question. So my third question was basically, I'll finish it. Just give me 2 more minutes. Okay, so introduce an error. I have introduced the error in the first bit. Okay, and find out the error syndrome. Error syndrome is nothing but to check whether that 1 bit error can be corrected, because in step number 2, what we have done, in step number 2, we have explained over here that your 1 over here, that your this t equals 1, so it can correct an error up to 1 bit. We have also practically made an error in 1 bit and see whether we can correct it. Okay, so it can detect 2 errors over here in this problem, and can correct 1 bit error. Okay, so that is what we have done, and we have got the answers to all the questions. Okay, so this question number 1, question number 2, and question number 3, that is find out all the codes. Okay, so we have already found out all the codes using this form. Okay, then second question was to find out how many errors can be detected and corrected. Third one is we have made a mistake in one of the error, or one of the bit that we are sending, one of the code that we are sending, and checked whether we are able to find out where the error is present and replace that error. Okay, so this is how your block code. So question will come in this form. Okay, so generator matrix is given to you of block code 6,3. You have to find out all the vectors. Okay, correct, check whether how many errors can be detected and corrected, and introduce a single bit error, and try to find out the error syndrome. So this is all about your block code. Tomorrow we will learn, tomorrow is a holiday. Okay, sorry. So day after tomorrow, whenever is a lecture, we will learn what is a Hamming code. Okay, tomorrow's class, Friday's class, we will learn what is Hamming code. Saturday's class, we will learn what is linear code, and then only one code is remaining that we'll learn in the next class. Okay, so now I am just opening the forum to the students. Okay, just please, students, from 49 students, there are only 37 students now. Please unmute your mic, and just let me know if you have any error, if you have any difficulties. I will.
Excuse me, sir.
Yes. May I know who is this?
So in the last step, we got
Vedangi.
the matrix
Yeah.
as 110. So
Correct.
compared H and you found out that the first column has is the same as the
Correct.
answer.
Yes.
So, but then how you came to know that the error first bit? Why you did one? I didn't understand this step basically. I don't know.
Equal to you all. Am I audible, students? Am I audible to you all? I have not left the meeting as of now. Please don't leave the meeting. Am I audible? Okay. Okay. So Vedangi is there here. She had left the meeting. She had asked me a question. Vedangi, you're there? Yes. Okay.
Yes, sir. So just explain the last step, so
Can you
that's
see the
all.
screen? Can you see the? Okay. So
Yes,
where we
sir.
have done that. So what was the actual message that we wanted to send is this, correct? 0111100, correct? But what we did is we did one mistake. Okay. There was one bit error, that is 0 was converted into 1. Okay, so this is nothing but your h is what, this whole h is nothing but your actual message. Okay, so first bit error, there was a first bit error. What we did to find out the error syndrome, we did h into r transpose. Okay, we did this calculation, h into r transpose. Okay, now after finding h into r transpose, what do we get? Okay, the answer that we get is 110. We just have to compare this answer with the actual h is nothing but this. Okay, I just need to compare this 110. Okay, am I still there, or have I lost the connection again? Okay, am I audible again? There is some net issue over here. Am I audible? Okay. Uh, okay. So what I was doing, what I was told over here is nothing but I have not covered much over here. So this is the value of H, okay, and this is the value of R, okay, R transpose. I have multiplied it. Answer that I'm getting is 110. I am comparing this 110 bit over here. Which of this is having 110? Okay, when I compare this, I find out that the first bit over here is showing me the answer as 110. That I have got over here. The moment I identify this as 110 is first bit, that means that my first bit of transferring has an error. Okay, initially my first bit was 0, and while transmitting, the value was converted to 1. So I'll just compare it with this 8 bits. Okay, and whichever bit shows the output will be your error bit. Okay, now Vedangi, don't get confused. So if your output over here was 111, okay, if your output of this matrix multiplication was 111, I will simply compare this 111 with your H. Okay, now where is this 111 present? Over here your 111 is present. That means that your error is present in the third bit. Okay, that means your error is present in your third bit. Okay, is it clear, Vedangi?
Yes, sir.
Okay, fine. Anybody else? Anybody else is having any difficulty? I'm extremely sorry I've taken the class, but I cannot leave this concept in between. I cannot take half problem today and half problem tomorrow. It is very difficult for me. Now, and if you understand this concept properly, I am 100% sure Hamming code, linear code, ISBN code, cyclic code, you will be able to solve it very easily. That is my promise to you all. But just see to it that you have understood this concept today. I'm open. This forum is open. You can ask me question anytime by calling, by WhatsApp, by email, by any medium. But this concept of block code should be very much clear in your mind. Okay, we will solve different problems. There are hardly few problems based on this, but I will try to find out more problems and solve. Okay, if you all are not asking me any question, I'm going personally to each one of you. Aarti, did you understand what we have done today? What is a block code? How we have solved the problem of block code? Did you understand, Aarti? Okay, great. Anusha, did you understand what we have done today? Anusha, did you understand what we have done today?
Yes, sir.
Darren, what about you? Did you get what we have done today? Did you understood each and every step? Darren Fernandez, did you understand? Okay. Melroy, did you understand what we have done? Melroy, what about you? Nigel? Nigel?
Yes, sir. Understood. I have to go through it again, sir. But
Yeah, just go through it. If you solve this problem, I was supposed to tell you the same thing. All of you all, please solve this problem once again. If you solve this problem once again, you will come to know where you are facing difficulty. You can ask me the doubt, and also you will be able to understand it more clear. Okay.
yes.
Okay. I wanted to ask Mansi. Mansi is there today. Mansi is not there, I think. So no. Okay. Mansi is not there. Wellston, did you understand what we have done today?
Yes, sir.
Okay, that's great. So I feel most of the people who have asked have understood what is the what we have done today. What is the block code? What is the Hamming distance? What is the minimum Hamming distance? All those you have understood. So that's all from my side today. Please don't miss any of my classes that I'm telling now. Not only mine, of all the subjects. Whatever we are teaching at the last moment in final module is very important. Most of the questions what we are teaching now is asked in the exam. All of you know there will be a centralized exam for all of you. It won't be like previous exams how we have conducted. We are only sending the paper, you are getting the paper, we are only correcting the paper. Nothing, things are not going to happen like that. Already paper has been set of all different faculties from different departments have already set the paper. It will go to the university. University is going to conduct a centralized examination for all of you. How they are going to conduct is a different thing. But please don't take this lightly. Last time there were 15 students who have failed this examination. If you miss my classes, if you don't solve the problem, you will fall into trouble. Please do not miss my remaining 4-5 classes, whatever is there. This week there are 2 classes remaining, and next week there are altogether 3 classes which is remaining. I'm not going to trouble you after that. Okay, so please be present. Thank you very much for attending my class for 1.5 hours. Okay, thank you very much. Okay, that's all from my side. If you have any difficulty, please get back to me in any form, either in WhatsApp, email, phone, anything. Okay, thank you very much.